Hello everyone, how are you all? I hope you all are doing good and welcome back to Vishnusmartinfo. This is your track 2 physics mentor, this side Charu Sharma. And after a very long time, like almost a 1 week over, there was no video from track 2 physics. So no need to worry. Actually, I was busy with my family, relatives and everyone celebrating Diwali. And happy Diwali to all of you. And I hope all your wishes come true. Now, the reason is I could not shoot the video because I did not find any time and space to shoot. And when once some cousins are at your home, you don't feel like studying. So here teaching was also becoming very difficult for me in that time. But now I have returned home and now the videos will be back as normal. And for your kind information, this video which I'm shooting now, this is like almost it is 5:15 in the morning. So I'm shooting for you all guys in the morning, so my voice is also like that only. Because I don't want to delay anymore, I'm shooting this video. I just came back the last night home, 12 o'clock, and now I'm shooting the video for you all. So please guys, this is the effort which we are putting from our side. Okay, sometimes there are problems like we could not manage time or something, but for that I gave you some homework also in Telegram that you can practice the previous chapter and start studying by yourself, and whatever your backlogs you would have completed in this time. Okay, so when we are trying so much, you should also try to your level best and support. And how can you show your support is in the form of likes. I was really very disappointed when I saw just 9 likes for the first part of mechanical properties of solids. This is not the way you react, right? You should, when you come to a video, at least put a like, because how much effort we are putting to shoot that video and to bring it out to you, for that like is very small thing. Just one thumbs up you should do, right? Just you need to press one click. So please do like the video, share it with your friends, subscribe the channel. Okay, so today is in the last class, mechanical properties of solids, I told you all the basic terms like what was stress, what was elasticity, what was plastic nature, what was strain and longitudinal strain, longitudinal stress. So all these terms I have already explained you in the last chapter. So if you're feeling any doubt, you can just go back to that first video, mechanical properties of solids part 1, and you can clarify all your doubts over there. Okay, so all the important terms like bulk modulus, what is bulk modulus, what is Young's modulus, what is rigidity modulus. So all these have been explained over there. Now coming to this video, in this video I am going to explain Hooke's law, because this graph is very important, and like you can expect 90% of a question from this graph only. For NEET and all these papers, though, there is no expectation question can come from anywhere. But when coming to mechanical properties of solids, if they want to make a paper tricky, they will put a question from this area. So I thought of dedicating just one video for this topic. Okay, so and one more thing, I found a reason that people are not staying on the video for a long time because they're finding it a very long, like 30 to 40 minutes time period video. They're finding it very long. So I thought, why not let us break it into parts, like just a 16 to 17 minute video giving you a clarity on a topic. So you will feel, okay, 15 minutes we need to give and we will get one topic. So that is the thought I was happening in my mind. So let's begin today's class. So firstly, we need to understand what is Hooke's law. for today's class. And I'm saying, don't say in the comment box below that what is stress, what is strain, you didn't explain it. I already did in mechanical properties of solids part 1 video. Link will be in the description box below. You can find it there. And you can go to the previous video, because the gap between the mechanical properties of solids part 1 video and the second video part 2 is a very long gap. It's just a gap of 1 week because I was on Diwali vacation. Okay. So Hooke's law. What is Hooke's law? Hooke's law states that Hooke's law. It states that stress for an object will be directly proportional to strain. Okay? Stress is directly proportional to strain. For example, this is a object. Okay? And I am applying on this much area. Let me consider this area A. And on this area A, I am applying a force F. So what will be your stress? Force upon area. So how much stress or like pressure, it is a quantity just similar to pressure. So how much stress is made on this body, that much strain it will produce. For example, if I am pushing it like this, probably this may shift towards this much. So this much elongation can be seen. Okay, so this much elongation can be seen. That elongation will be in the part of strain. So how much stress you put, that much strain will be coming, is statement by Hooke's law. That is natural, na? మీరు ఎంత ఫోర్స్ అప్లై చేస్తే అంత బాడీలో స్ట్రెచ్ వస్తుంది కదా. ఒకవేళ ఒక రబ్బర్ ఉంది, మీరు ఎక్కువ ఫోర్స్ అప్లై చేసుకొని స్ట్రెచ్ చేసుకున్నారు, అంత స్ట్రెయిన్ వస్తుంది ఆ రబ్బర్ మీద. ఫర్ ఎగ్జాంపుల్, ఇది మన రబ్బర్, నార్మల్ యూజువల్ రబ్బర్ యూజ్ చేసుకుందాం కదా. ఈ రబ్బర్, దీన్ని మనము ఇట్లా స్ట్రెచ్ చేసుకున్నాం, స్ట్రెస్ అప్లై చేసుకున్నాం. అప్పుడు ఈ రబ్బర్ ఇంత స్ట్రెచ్ అయింది. సో దీనికి స్ట్రెయిన్ ఎంత? దిస్ మచ్ ఇస్ ద స్ట్రెయిన్. హౌ మచ్ ఇస్ ద ఎక్స్టెన్షన్? తన ఒరిజినల్ పొజిషన్ నుంచి వేరే పొజిషన్కి. ఇప్పుడు ఈ ఫోర్సే మనము ఇంకా ఎక్కువ అప్లై చేస్తే, ఇంకా ఎక్కువ అప్లై చేసి ఇంకా స్ట్రెచ్ చేసుకున్నాం ఈ రబ్బర్ని, అప్పుడు మళ్ళీ ఇంకా స్ట్రెయిన్ వస్తుంది కదా, రైట్? కానీ ఇట్లా ఫోర్స్ అప్లై చేసుకున్నాం, ఒక పాయింట్ వస్తుంది, అక్కడ ఈ రబ్బర్ బ్రేక్ అయిపోతుంది, ఇంకా స్ట్రెచ్ అవ్వలేదు, అక్కడ బ్రేక్ అయిపోతుంది. ఆ పాయింట్ని మనము ఫ్రాక్చర్ పాయింట్ అంటాము. సో ఇలాంటివి డెఫినేషన్స్ వీఆర్ గోయింగ్ టు లెర్న్ ఫ్రమ్ దిస్ గ్రాఫ్, విచ్ ఇస్ స్ట్రెస్ అండ్ స్ట్రెయిన్ గ్రాఫ్. ఐఎమ్ నాట్ వెరీ గుడ్ అట్ Telugu, so I'm trying to be okay with it, okay? Because many people were saying, please try to speak in Telugu here and there so that we can feel that we are learning in Telugu. Okay, so I am trying my best to try to speak in Telugu, but I'm not very good at it. Okay, so now where the rubber will break and where it will not come to its original shape back again. So all this area or scenarios will be discussed from the stress and strain graph. Okay, this is a very important graph of Hooke's law, which is stress and strain graph. So in this, the graph is like this. The black line you can see is the graph. Okay, so this is the graph. Don't worry, notes will be posted on Telegram. So like this, at the end of the chapter, the notes will be posted. So this is the graph. So this means, like, once you started putting stress on a body, it will start showing some strain on it. So as you increase the stress, strain is also increasing. That means stress is directly proportional to strain. So up to a limit, the stress will be directly proportional to strain. up to that limit, we will call it as proportional limit. So A point will denote proportional limit. Means up to which region stress is proportional to strain. Till now I wrote na stress is proportional to strain. Right? Stress is proportional to strain. Till I wrote that only. So up to what limit stress is directly proportional to strain? That is known as proportional limit. Okay, proportional limit. And from origin to that proportional limit, we will show that object will be showing elastic behavior. Means an elasticity, that you stretch it and if you leave it, it will again regain its own shape, its original shape. There will be no deformation in its shape. Then shape change కాదు. మీరు స్ట్రెచ్ చేసుకున్నారు, మళ్ళీ వదిలేస్తే మళ్ళీ అది ఒరిజినల్ షేప్కి వచ్చేస్తుంది. తన షేప్లో ఏం చేంజ్ రాదు. ఓకే, సో అప్పుడు వరకు మనము ఎలాస్టిక్ బిహేవియర్ చూపిస్తుంది అని చెప్పవచ్చు. కానీ ఒక పాయింట్ వస్తుంది, ఆఫ్టర్ ప్రొపోర్షనల్ లిమిట్ మీరు ఇంకా స్ట్రెస్ అప్లై చేస్తే అది like proportional only graph will go, but little bit variation is there, very little variation. Can you see this variation? Very little variation. When you increase the stress but strain, you see it's not directly proportional. It's like this. The graph came like this. This will show that it is stretching, but it has come to a limit called elastic limit. After this, there won't be any more elasticity. Okay, elastic nature will be lost after point B. After up to A point, stress was directly proportional to strain. Then up to B point, there was some change in stress directly proportional to strain. And that B point we will call as elastic limit. After this, no elasticity. This is the limit of elasticity. After this, you apply more stress, there will be no strain. Means there will be strain, but it won't be in the manner of directly proportional. Okay, now next point will be C point. That point indicates C point, like suppose you applied more stress and there is strain, but now original shape will be lost because you have applied stress after elastic limit. After elastic limit, you have applied more stress. So original shape is lost. Because what does elastic nature means? Elastic means after you apply stress, the body will regain its own original shape. That means elasticity. Okay, so once you applied stress, it's coming back to its original position. You applied on this object. On this object, you applied stress. So you applied like this. You're stretching it. So up to a limit it will stretch. Up to a limit it will stretch. That will be its elastic limit. After that you stretch any more, it will try to produce some strain. But when you leave it, it will not gain its original position. Its original position was here. Its original shape was here. But no, it will not get some original shape. It will get some deformation. Some 1% shape will be changed. Less than 1% there will be change in the shape. So that's C point. After B point, there will be a point called C. So from the origin up to this C point, this part is known as plastic behavior. What does plastic behavior means? That once you apply stress, the original shape is lost. The original shape is lost. So you can see here original shape is lost. There is some 1% deformation. And this point on the x-axis, you will call it as permanent set. That means there is some permanent deformation in the object, permanent set. Okay. Next, coming to point called D. That once again you increase stress. After C point also there was some permanent set and deformation, but still you wanted to increase the stress. You still increase the stress. What will happen? It will stretch, and the graph is not in a normal way. The normal graph should be like this, but you can see how it is. It's having some deformity. And At D point, the object will break. That is called as fracture point. That is called as fracture point. Now C to D point, this area, you can call it as plastic deformation because there will be deformations in the object shape. Suppose if you stopped here and you bring back the shape of the body to the original x-axis, you will see how much change in the original shape will be. So on this axis you can plot the change in original shape. Suppose I stopped before fracture point. So if I bring this graph again like this till here, you can see how much change in the original shape is from here to here. Understood? So I will explain again, once again, revision. So up to where stress is directly proportional to strain obeying Hooke's law, that is called your proportional limit, point A. Next, after point A, there will be a limit called elastic limit. After elastic limit, you can't see any more elasticity. That is the limit of elastic nature. And after that, the body will not regain its own shape. Till B point also, if you leave the stress, if you remove the stress, the body will come back in its original shape. There won't be any deformity. But after elastic limit, if you move to a point C, then if you remove the stress, the body won't regain its own position. It will have some permanent set, and that point, up to that point, you can say that body is showing plastic behavior. Now from C to D point, fracture point. So D was the fracture point where body will break. So from C to D point, you can say the body is showing plastic deformation. Now there are some important points you need to remember regarding this graph. That is, first point I already told you that this part O to A is elastic behavior. Then O to C, or on x-axis to C, this is called plastic behavior part. Means this is elastic nature and this is plastic nature. Elastic nature means if you remove the stress, body can regain its own shape. Plastic nature means body cannot regain its own shape. Now from A to B region, this region is known as elastic region. Which region? Elastic region means in this region you can see elasticity. Okay, because after this point you remove the stress, there will be some deformation, but up to this point, this region ke point mein, if you remove stress, elasticity is still there. So it is known as elastic region. A to B. A to B is known as elastic region. Next, coming to B to D. This B to D, this is known as plastic region, means there is some deformity in its shape. Now plastic region, so there will be questions like if plastic like they will put some point here, so I put A B C D, they will put O E F, some letters they will put in the points, and they will ask you that, for example, here they kept M and here they kept N, and they will ask you if the MN was small in shape, means this graph they will give you similar graph here, similar graph they will give you like this, they will give you, and this was M point and this was N point. So this region you can see it's very small, right? This region is very small now. They will ask you now, what does this graph indicate? How is the body type? Elastic, brittle, can't say, like that options will be there. So by seeing graph, how can you tell body is elastic or plastic? Means, see, there is some concept. What I told you that A to B was elastic region and from B to D was plastic region. So if I say plastic region is small, what does this region means? That still the body is not breaking. How much the graph you go big long graph, it means that body is not breaking. మీరు స్ట్రెస్ అప్లై చేస్తున్నా ఈ బాడీ బ్రేక్ అవ్వట్లేదు. దాని మీనింగ్ ఏంటి? అది బాడీలో ఎలాస్టిక్ నేచర్ చాలా ఉంది. ఇక్కడ వరకు ఎలాస్టిక్ నేచర్, కానీ అది ఇంకా స్ట్రెచ్ అవుతుంది అన్నమాట. ఆ బాడీలో ఎలాస్టిక్ నేచర్ ఉంది. ఓకే, అందుకే దానికి ఫ్రాక్చర్ పాయింట్ అంత ఈజీగా రాలేదు. ఈ గ్రాఫ్ చాలా లాంగ్గా ఉంది. సో పాయింట్ సి టు డి, బి టు డి, ఈ రీజన్ ఎంత లాంగ్ ఉన్నా అంత బాడీని ఎలాస్టిక్ అంటాము. ఎందుకంటే మీరు ఎంత స్ట్రెచ్ చేసుకున్నా ఫ్రాక్చర్ పాయింట్ రాలేదు, ఇప్పుడు దాకా బాడీ బ్రేక్ అవ్వలేదు, ఇంకా స్ట్రెచ్ అవుతూనే ఉంది. అబ్నార్మల్ వేలో అవుతుంది కానీ అవుతుంది కదా. దాన్ని మనము ప్లాస్టిక్ రీజన్, ఈ B to D పెద్ద రీజన్ ఉంటే, లార్జ్గా పెద్ద గ్రాఫ్ ఉంటే ఫ్రమ్ దిస్ పాయింట్ టు దిస్ పాయింట్, దాన్ని మనము ఎలాస్టిక్ బాడీ అని అంటాము. కానీ ఒకవేళ B to D చిన్న గ్రాఫ్ ఉంటే, అంటే ఈ D పాయింట్ ఇక్కడ ఉడకుండా ఫ్రమ్ that D point not being here, if it was here just very close to B, what does that mean? But after applying some more stress, the body got break. Means up to a region it was having this elastic limit, and just after elastic limit some more stress you applied, it got break, fracture point it got. That means what? That body broke easily. If it broke easily, it means it is brittle in nature. Brittle means the body which breaks easily. Like you can say, for example, stone, not stone, like if you throw, or I can say a brick is there, you are trying to stretch up to a region, it will stress, there will be no deformation also, you can't see large deformation, and it will break off. That means brick is brittle in nature, right? And similarly, if I take a rubber, if I stretch, the fracture point won't come that easily, it will try to stretch, at some very far point it will break. That means this graph was very big for rubber, means rubber was elastic in nature. That's why fracture point was not close to elastic limit. And once fracture point is close to elastic limit, that means body is brittle, it will easily break off. Once you apply more stress, it is easily breaking off, means body is brittle. Okay, so remember, I told you na, this from B to D is plastic region, and from O to B is from A to B is elastic region, and from B to D is plastic region. So once the plastic region was very small, it means body is brittle, and plastic region is very big, it means body is elastic. Now there is a term called Young's modulus. So modulus means it is used like a proportional limit between stress and strain. So if I say stress is directly proportional to strain, so to remove this proportionality, I will use a constant. Stress is equals to Y into strain, or I can say Y is equals to stress upon strain. So this Y is nothing but your Young's modulus. It is a proportionality constant. Stress upon strain is Young's modulus. Like that you will have bulk modulus also. So in bulk modulus, what will be there? Volume stress, volume strain. In rigidity modulus, what will be there? Shear stress, shear strain. Okay. In Young's modulus, longitudinal stress, longitudinal strain. Okay. So all these modulus terms we will be discussing in the next video. In today's video, I thought of just giving importance to this graph. Now I want to give you a small homework. On this graph, there will be many interesting questions. So I will post that interesting questions on Telegram. At least 10 to 15 questions will be there. I want you all to do the questions and then come back to this video. Mechanical properties of solids, you need to come back to this video. And in the comment box below, all the 15 question answers you need to give. Like in your comment, you will write first one. How you need to represent this, I'll show. Like you need to tell first one option A, second one option B. Like that you need to put in your comments. And the one who is having questions correct, more than 13 questions correct, okay, or like more than 10 questions correct, out of 15 to 20 questions, more questions are correct for the person. I will tell his name in the next video, his or her, whatever it is. I will tell the person name in my coming next video for sure. Okay. And I am putting my best efforts. So you need to support by a like, right? So don't leave the video without liking it. Just put your thumbs up, like it, share it with your friends, and subscribe the channel. and that's how you can support, right? There is no other way. I hope you like the graph, stress and strain graph. It was very interesting, right? To know a body just from a graph, you can tell how. So it's like the person who are aiming to become doctors, it's in your future you will see these conditions only. Now from a graph you need to tell what's happening in the body. So similarly for a object, from a graph we can tell that how its elastic behavior is shown, how its plastic behavior, up to what limit is having elastic nature, up to what limit it will have fracture point, so proportional limit. So all these terms we discuss very clearly. Have a good day. Hope you all are doing well. Read NCRT. Don't leave your NCRT. Just put it as your, how you love your mother and put always, you want her always to be beside you. Similarly, NCRT you need to consider at least for these 2 to 3 years. Consider NCRT as your mother and put it not just beside you. You need to show your affection by reading it also. So mechanical properties of solids, you need to read the chapter. So on this graph you need to read, and there are few questions in NCRT also. So try to solve those questions and put the answers in the comment box below of the questions which I put on Telegram. Okay. So bye everyone. Have a good day. So today is one more thing I wanted to tell. Not bye. Today is Thursday, so this video is coming today. So on Thursday this video is coming. On Friday tomorrow also one video will be coming on modulus. I will tell on more about on this modulus, Young's modulus, rigidity modulus, all these modulus I will explain clearly, and some more relations. Then on Saturday I'll bring one more video on potential energy and all this, and we will complete this chapter. By Saturday or Sunday we will complete the chapter. So there was some break in the schedule, because what is the track to physics schedule is, the video will be coming on Monday, Wednesday and Friday. Okay, so on Monday, Wednesday and Friday, 3 days the video will be coming on channel for track to physics. So this schedule has been broken due to me only, because I took some holiday gap. Okay, so by Saturday I will complete this portion. So whatever the gap was there, it will get covered. And again from the next week, Monday, Wednesday, Friday, as usual videos will be coming. Tuesday, Thursday and Friday you need to solve your questions. So Monday, Wednesday, Friday you need to put on theory. Tuesday, Thursday, Friday you need to solve the questions. And Saturday and Sunday Saturday you need to revise. Sunday you need to put a test on yourself, and questions for Sunday probably will be shared on Telegram only. Okay, so I hope you all are doing good. Keep doing like that only, and try to put your best efforts anytime. Okay, wherever you want to put your best efforts, you need to put. That is very important. Okay, then bye. Have a good day. Okay, once I need to show this graph properly, so that who wants to take screenshot and make good notes can make it. Bye then. Have a good day.